right, well, welcome to our last lesson for Unit 3. Today we're going to be looking at the general form, which is the last of the three types of equations for linear functions. And we're also going to look at x and y-intercepts. So we'll start by looking at the general form of the equation for linear functions. And that equation is ax plus by plus c equals 0. So if I were to give you an example of that might be 3x plus 5y minus 8 equals 0. We look at that equation, the a would be 3, the b would be 5, and the c would be negative 8. So it's important that you look at the sign that goes in front of the number when you're labeling your a, b, and c. Now, when we're looking at this equation, there's some rules that we have to follow. First of all, a, b, and c cannot be fractions. In other words, no fractions allowed. And we also have to have all of our terms move to either the left or the right side of the equation so that a is always positive. So our a value, or the coefficient that goes with the x variable, always has to be positive. And so a lot of times we're just moving terms back and forth across the equation, or across the equal sign. And so we can go back to something I mentioned in a previous lesson. If we switch sides, we switch signs. And if you can remember that, manipulating the equations will be quite easy. All right, so let's take a look at a few examples here. The first couple examples have no fractions, so we don't have to worry about the fraction piece. But we do have to move everything to the left or right side of the equation to make x positive. And so this first equation says 2x plus 3y equals 6. The x is positive, so the 6 is what has to move over. So we're essentially subtracting 6 from both sides. Or if you remember, when we switch sides, we switch signs. 2x plus 3y, when the 6 moves over, it becomes negative, equals 0. For the next one, 4y minus 3x minus 7 equals 0. The x is not positive, so we're going to have to move everything to the right-hand side. So everything's going to be moving to the right-hand side of the equation. And again, when we switch sides, we switch signs. So the 3x will be positive, the negative 4y, positive 7 equals 0. Now, it doesn't matter what side of the equation the 0 is on, so we just write it so that the x is positive, and then we add our 0. All right, for c, we need to get rid of a fraction. So we have y equals 2/3 x plus 4. Well, the easiest way to get rid of that fraction is to multiply everything by 3. So 3 times y is 3y. 2/3 times 3 is 2, so we've got 2x. 4 times 3 is 12. We need to move everything so that the x is positive. X is already positive, so it's the 3y that we're going to move. So we're going to have 2x plus 3y plus 12. And again, it doesn't matter which side the 0 goes on. We'll put it here. Initially, we can easily have it on the right-hand side. It doesn't change our equation. For the next question, we've got y equals negative 1/2 x minus 3/2. So we're going to multiply everything times 2. So we can put brackets around the entire equation, or we can go through and multiply each individual term by 2. Both notations are accurate. So we're going to have 2y, negative 1/2 times 2 is negative 1x, and then minus 3/2 times 2 is a negative 3. Now we're going to have to move everything to make the x positive. In this case, x is negative, so we're going to be moving everything to the left. And again, when we switch sides, we switch signs. So we've got a positive 1x, or just x, plus 2y. The 3 has moved, plus 3. So if we don't move the term, we don't change the sign. So we're left with x plus 2y plus 3 equals 0. So the 2y didn't move, so the sign didn't change. All right, last question. We've got 2x minus 2/5 x minus 4/3 y equals 7. Well, we have a 5 and a 3 in our denominator. So our common denominator would be our lowest common multiple. And the lowest common multiple of 5 and 3 is 15. So we're going to multiply the entire equation by 15. So that means 15 times 7, 15 times 4/3, and 15 times 2/5. So 2/5 times 15 is 6. So we've got 6x. Negative 4/3 times 15 is negative 20y. And 7 times 15 is 105. Again, we need to move everything so that the x is positive. In this case, x is already positive, so we're just moving the 105. So 6x minus 25, or 20y minus 105 equals 0. All right, so that's how we convert to general form. If you have questions about this, go back and review the video. We're going to be using this general form in some examples coming up shortly. All right, so we're going to switch gears for a minute and talk about x and y intercepts. We've already talked about what an x and a y intercept is, but now we're going to look at how it relates to making equations. So if I was to look at my graph here, my y-intercept is where I cross the y-axis. The y-intercept in this case is 0, 2. The x-intercept for this graph is 4, 0. So whenever we're looking at a graph, the y-intercept is where I cross the y-axis, and that coordinate would be 0, y. And when I cross the x-axis, my x-intercept will always have a coordinate of x, 0. So for an x-intercept, the coordinate is x, 0. And for a y-intercept, it's 0, y. What's important for you to note is that when we're looking at an x-intercept, y equals 0. When we're looking at an x-intercept, y equals 0. When we're looking at a y-intercept, x equals 0. And it's that property that we're going to use for the rest of these questions. So we're going to look at a series of examples. Each example asks us to state the x and y-intercept and then sketch the graph. We are not going to rearrange the equation. We can rearrange the equation to find our y-intercept, but we're going to do it with the equation as is. So this equation is in general form, and we're asked to find the x and the y-intercept. Well, if you remember from just above, if we're looking for an x-intercept, that means that y equals 0. So we are going to sub y equals 0 into our equation and solve for x. So 4 times x plus 3 times 0 minus 12 equals 0. So 4x, 3 times 0 is 0, minus 12 equals 0. Add 12 to both sides. We've got 4x equals 12. Divide each side by 4. And we have x equals 3. Writing that as a coordinate, we have 3, 0. Now for the y-intercept, when we're solving for the y-intercept, x equals 0. So we're going to sub in 0 for x and solve for y. So 4 times 0 plus 3 times y minus 12 equals 0. 3y minus 12 equals 0. Add 12 to both sides. We have 3y equals 12. Divide by 3. And y equals 4. So our coordinate will be 0, 4. Once we have those 2 points, then we can graph our equation. And so we're plotting a point at 3, 0, plotting a point at 0, 4, and ideally using a straight edge to connect that graph. Okay? Clearly I didn't use a straight edge. All right, let's do another practice one. So we've got negative 2x minus 3y equals 6. To find the x-intercept, we let y equal 0, and we solve for x. So negative 2 times x minus 3 times 0 equals 6. So negative 2x equals 6. Divide by negative 2. X equals negative 3. And for the y-intercept, we're going to let x equal 0 and solve for y. So negative 2 times 0 minus 3 times y equals 6. Negative 3y, don't forget that negative. Okay, that's an important sign. Negative 3y equals 6. Divide both sides by negative 3. And y equals negative 2. So if we look at our coordinates, we're going to have negative 3, 0, and 0, negative 2. So we plot our points, 0, negative 2, negative 3, 0. And again, you should be using a straight edge. And we plot our graph. so there's a couple here for you to try on your own. So this would be an opportunity for you to pause the video, try the questions, and then come back and check your answers. So for the first example, we've got y equals negative 3x plus 2. Again, for x-intercept, we let y equal 0 and we solve for x. So 0 equals negative 3x plus 2. We subtract 2 from both sides, so we have negative 2 equals negative 3x. Divide by negative 3 on both sides. And we have x equals 2/3. For y, for the y-intercept, x equals 0. And so we have y equals negative 3 times 0 plus 2. So y equals positive 2. So my coordinates are 2/3, 0, and 0, 2. Now some of you might have been looking at that equation and saying, hey, wait, that's in y equals mx plus b form. And b is my y-intercept. So can't I just say 2? And absolutely you can. Notice that y equals 2 is 2. And we can do that because it's in the slope-intercept form. So we plot our points here, 2/3. 2/3 is about there. My board's a little bit off here. And 0, 2. And again, ideally using a straight edge. I'm not using the ruler today just to save some time. All right, next question. We've got 2x minus y plus 8 equals 0. Now, if it's easier, you can certainly rearrange your equation. But the idea behind the x and y intercepts is that we don't have to rearrange our equation to find the information. So for x-intercept, we're going to let y equal 0. So 2x minus 0 plus 8 equals 0. So 2x plus 8 equals 0. 2x equals negative 8. Divide by 2 on both sides, and we have x equals negative 4. So one of the points is negative 4, 0. For y-intercept, we let x equal 0. So 2 times 0 minus y plus 8 equals 0. Negative y again, remember that negative? Negative y plus 8 equals 0. So y equals 8. And so my coordinate there would be 0, 8. So we plot a point at negative 4, 0 and 0, 8. And this one I will use the ruler. It's a little too far to freehand. And we connect our points and make sure to always remember to put the little arrows at the end of your line. All right, so now we're going to go back to general form. And the first question here says, using the graph below, write the equation of the line in general form. Now, when we're asked to write something in general form, that's our absolute last step. We actually do everything the same way that we did in 3.5. We put it into either slope-intercept form or point-slope form, and then we convert it to general form. So we don't actually build the equation using general form. So when we're looking at our graph here, we want to find some key points, but we happen to know our x-intercept and our y-intercept. So we have a point here at 0, negative 4, and we have a point at 3, 0. Because this is also on a graph, and these are nice points, we can draw our triangle, and that gives us a run of positive 3 and a rise of positive 4. So our slope would be rise over run, 4 over 3. Make sure you don't mix up your rise and your run. When I was actually doing this question the first time, I made that mistake. And then I caught it later on when I was doing it a second way. So it's really important that you don't mix up your rise and your run. So our slope would be positive 4 over positive 3. And our y-intercept we can find from the graph is 0, negative 4. If you wanted to be sure using your coordinates, and this is how I caught my mistake, remember that the slope is y2 minus y1 all over x2 minus x1. So our coordinates would be 0 minus negative 4 all over 3 minus 0. gives me 4/3. Whichever way you choose to do it, we're still going to end up using the y equals mx plus b, and we would have y equals 4/3 x minus 4. I just noticed up here I'd written the coordinate. So the b value is -4. Now, that's our equation in slope-intercept form. We have to convert it to general form. So the first thing we have to do is get rid of our fraction. So we're going to multiply everything by 3. Okay, or you put brackets around to show you multiplied by 3. So that's going to give us 3y equals 4x minus 12. The x is positive, so we're going to bring the y over, and our final answer will be 4x minus 3y minus 12 equals 0. Notice the 3y is the only one that moved, so the 3y is the only one that changed signs. All right, so I just threw this example in here just as a refresher. We've talked about these exact equations before, but I just wanted to throw them in just to see if you remember how to write these equations. So if I have a vertical line that passes through x equals 2, this equation is going to be x equals 2. If I have a horizontal line that passes through -3, my equation is going to be y equals -3. So remember, for horizontal lines, it's always y equals a number, and vertical lines, x equals a number. Doesn't pertain specifically to this topic, but it's a concept that that people can often mix up, and so I wanted to make sure to throw it in just one last time. All right, so the last piece that we're going to look at is how to write an equation of a line, just like we did in 3.5, but then do the last step and convert it into general form. So the last 3 examples are all going to be just variations of the same thing. So example number 4 says, write the equation of the line that passes through -2, 5 and is perpendicular to 3x minus 2y equals 7. And again, we're going to be doing this in general form, but again, that's my last step. So everything else that I do is the same as what I did in 3.5. Now, in 3.5, I showed you 2 different methods for creating your equation. I'm only going to use one method each time. And if you prefer to use the other method, use the method that you're comfortable with. You should still get the same answer. All right, so for this equation, I'm told that the point is -2, 5, so that's my x and my y. And I'm told that I have to find a line that's perpendicular to 3x minus 2y equals 7. So the first thing I'm going to do is rearrange this equation to find the slope. So I'm going to have -2y equals -3x plus 7. I'm going to divide by -2. And I have y equals 3/2x minus 7/2. Now the 7/2 I'm not really concerned about because I only want to know what the slope is. For this equation, the slope is 3/2. I'm asked to find the perpendicular slope, meaning negative reciprocal, so that's going to be -2/3. So -2/3 is my perpendicular slope. For this one, I'm going to use y equals mx plus b. Y is 5, m is -2/3, and x is -2, and I'm solving for b. So 5 equals -2/3 times -2 is positive 4/3. Again, you can use your calculator to help if you're struggling with that. I want to get b by itself, so I'm going to subtract 4/3 from both sides. Again, use your calculator to help you out if you need. 5 minus 4/3 is 11/3. Remember math frac. So my final answer here as an equation is -2/3 x plus 11/3. If I've lost you on how to turn that into an equation, go back and review the 3.5 video. The final step to put this into general form is to multiply everything by 3. So we're going to have 3y equals -2x plus 11. We're going to move the 2x and the 11 to the other side, and I'll have 2x plus 3y minus 11 equals 0. Notice the 3y didn't move, so I didn't change the sign. So my final answer is 2x plus 3y minus 11 equals 0. All right, another example. Determine the equation of the line in general form. So again, that's our last step, that passes through point 1, 3 and is parallel to 3x minus 2y plus 8 equals 0. So my first step is to figure out the slope. So I'm going to rearrange this equation. I'm going to move the 2y over, so that's going to give me 3x plus 8 equals 2y, and I'm going to divide by 2. You may have chosen to rearrange your equation in a different way. You should still get the same answer. So 3 over 2x plus 4 equals y, or y equals 3 over 2x plus 4. Again, all I care about is the slope. The slope of that line is 3 over 2. The slope of the parallel line is also 3 over 2. This time I'm going to solve using the point slope form. I'm going to use y minus y1 equals m times x minus x1. So y minus 3 equals the slope of 3 over 2 times x minus 1. Multiplying everything through, I'm going to have 3 over 2x minus 3 over 2. I need to get rid of my equations. So I'm going to, not my equations, I need to get rid of my fractions. So I'm going to multiply everything by 2. Now you could have moved the 3 over to begin with. I just chose to do this at this point. 2y minus 6 equals 3x minus 3. I need to move everything to keep my x's positive. So I'm going to have 0 equals 3x minus 2y, and a negative 3 plus 6 becomes a positive 3. So my final equation is 3x minus 2y plus 3 equals 0. Again, if you had chosen to simplify all the way before multiplying everything by 2, you should still get the same answer. All right, one last example today. The last example says determine the equation of the line that passes through the point negative 3, negative 7 and is perpendicular to the line with the equation 4x plus y equals 9. And then we're asked to write the equation in general form. So again, start off with the equation, or start off with the slope. We've got 4y plus 9 equals 0. That means that 4y equals negative 9, divide by 4, and y equals negative 9 over 4. Now, if I look at that equation, it might be difficult to originally figure out what your slope is. So let's rewrite it as y equals mx plus b. I have no x, so that means I have 0x minus 9 over 4. That means that my slope is 0. If my slope is 0, that means it's a horizontal line, and perpendicular to a horizontal line is a vertical line. And if you remember Johnny falling off the line, that's an undefined slope. So if I have a line that's undefined and goes through a point negative 3, negative 7, a vertical line going through negative 3, negative 7, vertical lines are x equals, it's going to be x equals negative 3. All right, so hopefully that gives you enough examples. Again, we're doing a lot of building of equations just like in 3.5. And these would be the questions, that you would see the most often. These would be the questions that would involve the most steps. Now, I just realized I haven't actually finished the question. It says to put that in general form. So in general form would be to rearrange it so that it's in ax plus by plus c equals 0. That means my x has to be positive, which it is. I need x. There's no y, so I'd have plus 3 equals 0. So there's the final equation, not just the x equals negative 3. All right, so now I've done the example, and this again was the last lesson for this unit. If you have any questions, go back and review the video a few more times, and always remember that I'm in class if you have questions. All right, thanks, and have a great night.